Thank you, Anna, and welcome everyone. Thank you all for joining us. The purpose of today's webinar is to discuss the importance and challenges of accessible road transportation and its impact on the quality of life of people with disabilities, as well as to discuss some of the potential for new and emerging modes of transport, including shared automated vehicles, to address some of the existing barriers to accessible transportation. It is my pleasure to introduce both of our presenters today, whom I have known for many years now, and we have collaborated on multiple different projects, Drs. Jordana Maisel and Victor Paquette. Dr. Jordana Maisel works at the intersection of research, teaching, and practice as an assistant professor in the Department of Urban and Regional Planning at the State University of New York at Buffalo. Dr. Maisel is also the director of research at the University of Buffalo's Center for Inclusive Design and Environmental Access, also known as the IDEA Center. She is an accomplished researcher and author in the area of inclusive design. Our second presenter is Dr. Victor Paquette, who is professor and chair of Industrial and Systems Engineering at the State University of New York at Buffalo. His research focuses on the development and evaluation of systems that improve the health, safety, and performance of people with people in various environments, with the particular emphasis on those with physical limitations. Jordana, Victor, it is my pleasure to again welcome you to today's webinar. Thank you for accepting our invitation to present, and we all look forward to your presentation. Over to you.
Big thanks to you, Clive, and to the whole Ideal RRTC for inviting Victor and I to speak today. It's really nice, once again, collaborating with Clive. So just to dive right into it, since we only have a limited time together, this is a photo of where I'm currently sitting, Hayes Hall on the University of Buffalo South Campus. Victor will be presenting from the other campus, but this building is the home of the IDEA Center that Clive mentioned, where a team of really diverse experts collaborate on work related to advancing equity and inclusion for underrepresented populations. And we work across all domains of the built environment, but for the purposes of today, I want to focus on some of our transportation-related efforts. And so, just as an overview of our objectives today, I'm going to start by summarizing the importances and challenges of inclusive transportation, particularly for people with disabilities. Talk about how we need to consider the entire travel chain when we're thinking about an inclusive transportation system. Then we're going to switch and talk more about the evolution and the emergence of shared automated vehicles and the role they can play for assisting individuals with disabilities particularly. And then we will conclude with some ongoing and recent projects that we have been a part of. So without further ado. So before we talk about where we are, I think it's important to take a step back and talk about the importance of transportation in general. Transportation, and specifically transportation access, is really critical for ensuring employment, citizenship, social role participation, and really social interaction for all. And ultimately, economic independence and self-sufficiency are really only possible when transportation is accessible, affordable, and available, and when it's close to people's homes and to the destinations that they want to reach. And so, unfortunately, many people with disabilities experience these barriers due to a lack of accessible transportation, and this has severe consequences. So particularly individuals with disabilities, really, there's an employment gap between individuals with and without disabilities, particularly due to a lack of transportation. So again, this is not without consequences when we don't think about transportation access. Now, the photo on your screen is just an image of downtown traffic or on a highway with lots of cars and automobile traffic. Millions of Americans experience transportation barriers, and these barriers are exponentially worse for the 61 million Americans, or approximately 25% of all adults who have a disability. And people with disabilities typically have a more frequent need for healthcare, require greater accessibility to transportation, and have lower incomes than the general population. So current statistics suggest that approximately 26 million Americans report having a travel limiting disability. And that's a disability that makes traveling outside the home difficult. Approximately 4 million people with disabilities cannot leave their home because of transportation difficulties. And of those 26 million Americans with those travel limiting disabilities, over 11 million of those are 65 years and older. So this image is of a man in a manual wheelchair using a lift to leave a paratransit vehicle. And so even though we do have services available for people with diverse abilities, limited fixed route bus service areas, the physical barriers in the first and last mile, which I'll touch on in a little bit, and poor information access often prevent large sections of society from using our bus and rail systems. And so these barriers to access increase the demand and costs for paratransit service, which is the image you see here of door-to-door service, which is the most expensive form of accessible transportation and a major burden for transit operators. And so even though these paratransit services provide a vital link to community activities, people with disabilities report many barriers to their effective service, including schedule issues and long wait times. So there is an incentive for both transit agencies and riders to seek a better solution. So in addition to the actual transportation services that exist, we can also highlight some of the barriers that exist in the actual vehicles that are on our roads. So this is an image of an older man trying to get in and out of just a personal sedan vehicle, and the challenges that are just involved, even with private automobiles, getting people in and out of them safely and efficiently. This image is of an individual using wheelchair securement system on a fixed route bus, and the transit operator approaching her to assist in one of the tie downs. And securement is another critical area that we'll explore in a little bit, where we need to address some design challenges that exist. And we know from research that approximately only 30% of people are successfully tied down and secured on transit vehicles. So tremendous room for improvement with securement is needed. And so when we think about the accessibility of a transportation system, it really, again, has to be understood from the perspective of the entire travel chain, which is the image you see on the screen here, the different points in the travel chain. And so the research that Dr. Paquette and I have been working on over the past 15 years has really started to explore a lot of different areas of this travel chain to identify accessibility and usability challenges that exist across the chain, to identify which problems are most relevant to different user groups, and then to try to identify opportunities for improved transportation service across these different points in the travel chain. So just to outline some of these points, the links in the travel chain include trip planning, traveling to the station and stop use, boarding the vehicles, using the vehicles, leaving the vehicles, and possibly transferring, and traveling to the destination after leaving a station or a stop. So if you think about it, if one link in this chain is not accessible, then access to a subsequent link is unattainable and the trip cannot be completed. So thus, the travel chain really defines the scope of potential research and development in accessible transportation. And so what I thought I would do here is highlight some of the work we've been involved in at different elements of the travel chain really quickly. We don't have time to go into too much detail on each of these, but happy to follow up if anyone has questions about any of these research projects. So the first project and the first area I want to focus on is trip planning. So this is an example of an app that colleagues of ours at the Robotics Institute at Carnegie Mellon University developed. They developed this with a group of individuals with disabilities who were really heavily involved in the design and development process. And this was all about designing an app to assist with trip planning for fixed route bus system. And so they learned quite a bit, and the users recommended things like knowing when a bus is full, having information on the app, knowing when a bus is full, having the ability to share pictures and information about the riding experience, and being able to text. And you can also see this evolution of the app where a filtering system was implemented to reduce the noise and the burden of information that someone had to sift through in order to get the critical information they wanted. The next area is, the next step in the travel chain is that first last mile problem. And that's the inability to really get to and from destinations, including stops and stations, which results in that lack of mobility and often leads to the dependence on that expensive, burdensome system, the costly paratransit that I mentioned earlier. And ultimately, every transit rider is a pedestrian at some point in his and her trip. So it's a really important step in the chain. And so that term of first last mile refers to that distance between an individual's home and the nearest transport hub. So it's really the beginning or last leg of any travel episode. So the physical environment of that first last mile is comprised of public rights-of-way that includes sidewalks, roads and bicycle paths, street crossings, and all the pedestrian controls that are involved in those. And for people with mobility-related disabilities, the interaction between their functional capabilities and the characteristics of that first last mile can often dictate that need for paratransit over a fixed route transit use or a different type of transit option. So thus a safe and really a safe and navigable pedestrian environment is really a key determinant to the accessibility of transportation systems. Next, we have the transit stop, and this is where we're not just waiting for the vehicle to arrive, but we're trying to identify and confirm that the vehicle is actually the vehicle we need and requested. And it's also that linkage between the infrastructure, the urban infrastructure, and the vehicle, which you're going to see again later in the presentation has become a critical area of the intersection between autonomous vehicles and pickup zones and loading. So our sidewalks and pavements and those curbs are really rapidly becoming a new focal point of concern for congestion due to the steep rise in things like e-commerce, ride hailing, active transportation, and micromobility. Our sidewalk areas here are getting quite crowded with a lot of different things that we need to figure out how they all work together. The next area is actually boarding the vehicle. Dr. Briquette and even Dr. DeSouza have been involved in many research studies related to ramp slope and the boarding of vehicles. So the transportation safety literature really reflects serious passenger concerns with boarding and disembarking vehicles. And one of the most serious challenges is access by people who use wheel mobility devices. A challenge for the industry, and we'll get into this again in a little bit, is really the development of very low floor vehicles or kneeling features that reduce the ramp slope required for boarding. So it reduces the angle of that slope, making it less burdensome for people to board the vehicle. And that's what we're trying to achieve, but it's proving quite challenging in the design of some newer vehicles. Ramps also need other features that make them safe for all passengers, like individuals who are blind or visually impaired and older people using canes and walkers. So again, we're not just thinking about one population group, but also the diverse needs across different user groups. And then when we're riding the vehicle, I touched on securement a little bit earlier, but again, there's a lot of room for improvement in the world of securement. As I mentioned, only 30% of users are properly secured on vehicles, according to research. And so the success of any automated vehicle technology that is covered by legal requirements and accessibility requirements, like shuttle buses and shared van services, really ultimately depends on developing a system that can be used independently and ideally one that is front-facing, So on the image on the right, you see an individual in an independent securement system, but she is rear facing in her scooter. The images on the left are more of the traditional tie-down systems. So we need to think more creatively about the future of securement because many passengers do not prefer to ride backwards, and we have some research on that as well. And so securement really is an issue for all passengers. One could ask, who is liable if a passenger of an automated vehicle doesn't use their seatbelt when the device is clearly difficult to use? And we have to think about proper securement for children as well. So it's really a universal problem. And so lastly, just some of the takeaways with regards to the travel chain is that, again, we need to think about usability across that travel chain, getting diverse stakeholders and user groups involved in the research and design process is critical. Having different minds collaborating on this from different backgrounds and expertise is really interesting and critical. And while a lot of the research tends to address the needs of different individuals with mobility limitations, we can't neglect individuals who have sensory cognitive issues as well. And expanding a little bit beyond addressing the needs of individuals with disabilities, we need to focus on issues related to social equity, about the cost for some of the systems moving forward. What if people don't have access to smartphones and banking systems, et cetera? So thinking broader about who we can address in newer transportation systems so that we are more inclusive. And with that, I am going to turn it over to my colleague.
Thank you, Jordana. Automated transportation and its benefits. Next slide, please. This slide summarizes the Society of Automotive Engineers' levels of driving automation in table format. The Society of Automotive Engineers classifies vehicle automation into 5 levels, with the lowest, or level 0, being primarily manual or informational in nature, to level 3, where the vehicle can ask the passenger to take over at any time, to level 5, where the vehicle is fully automated in all conditions. For this part of the presentation, when I talk about automated or self-driving vehicles, I'll be describing level 4 and level 5 technologies, where the vehicle is fully automated either in a limited set of environmental conditions, which would be level 4, or all environmental conditions, which would be level 5. Level 4 and level 5 technologies have the ability to transform transportation for all, and in particular for those with limitations, if the user needs and preferences are considered throughout the travel chain. Next slide, please. There are now many different manufacturers of self-driving vehicles, ranging from the very small to full-size buses and trucks. This slide shows a small 2-passenger automated vehicle. Next slide, please. This slide shows a self-driving shuttle developed by EasyBio. It can carry a maximum of up to 12 passengers. The shuttle has a low chassis and a tall door opening that can aid boarding and exiting of the vehicle. Next slide, please. This slide shows another self-driving shuttle design developed by Local Motors. In this slide, there are individuals inside the vehicle. The vehicle is known as the Ollie. It has many of the same physical characteristics as the Easy Mile version, but is no longer being produced. Next slide, please. This slide shows Waymo self-driving sedan. Waymo is Google's self-driving car division. The illustrations that I've shown to this point, including the one here, have vehicles that have very few, if any, accessible design features. There are many design considerations that must be met to ensure those with physical or perceptual limitations have a positive user experience with automated transportation. And next slide, please. This slide shows a self-driving shuttle with passengers already seated. A boarding ramp has been deployed and a power wheelchair user is pictured to begin ascending the ramp. While the shuttle at least is equipped with a ramp, it is clear that the ramp slope is fairly steep and that there is little remaining clear floor space in the vehicle to accommodate the space requirements for the power wheelchair user to safely board the vehicle. Next slide, please. This slide shows two individuals interacting with the display mounted in the interior of a self-driving shuttle. It's critical that passengers of self-driving vehicles have access to the information they need to enjoy their riding experiences. Passengers will have individual needs and preferences about the mode of display, for example, visual, auditory, or tactile, the types of information they would like, and how to interact with the vehicle or transportation service during normal and unexpected events. Next slide, please. This slide shows the interior of a self-driving vehicle with two individual monitors showing dynamic navigational displays that feature the vehicle location throughout the trip. Next slide, please. This slide shows a self-driving shuttle pulled up against a raised and covered shuttle station to make boarding and exiting much easier for passengers with mobility limitations. This imagery is included here to demonstrate the importance of understanding the interaction between the vehicle and the environment to support successful travel experiences and that are supportive of designs that eliminate barriers in the travel chain. This can make an incredible difference in the experiences of those who have travel limiting disabilities. And I'll now pass the presentation over to Jordana.
And so when we were developing this presentation, we thought it was important to really, the term inclusive design is often thrown about, or universal design. And so we thought it was important to share the definition and the knowledge that we use to ground the work that we do. So you've heard us talking quite a bit about accessibility, inclusive design, universal design, and there's often question, are these the same thing? Are they different? And so we feel it's important to share. When we say universal design and inclusive design, we're meaning the same thing. But accessibility is something different. Accessibility is code compliance, minimal access, where inclusive design or universal design is really about going above and beyond that. So when we say universal design or inclusive design, we see it as a process that enables and empowers a diverse population by improving human performance, health and wellness, and social participation. And so oftentimes accessibility often stops at that human performance part. And so we think much broader about how do we prevent accidents and address safety concerns through health and wellness ahead of time. And then how do we ensure we're creating designs or environments that allow people to engage in the community the way they want to and be integrated in the community and not just have a design that's accessible but separate. So again, this is our definition. We use these three outcomes to really guide the work we do, and all of this is grounded in 8 goals of universal design that is linked to bodies of knowledge, things like anthropometry, biomechanics, perception and cognition, and social participation design parameters and spatial syntax. So again, it's a way to orient the thinking when we're talking about inclusive transportation. And this is not just a theoretical exercise, it's actually being applied and used. There was back in 2019, the Auto Alliance, or the Alliance for Automotive Innovation, I believe they're now called, they hosted a 3-part workshop series before the world came to a crashing halt for a couple years. And it was an exciting workshop series. Dr. Paquette and I collaborated in that series, and it brought different stakeholders from industry, from academia to actual end users to talk about the user needs and what are best practices in ensuring an increased accessible AV design, automated vehicle design. And at that time, we proposed the use of the goals to guide the thinking across the travel chain, and thrilled that they actually adopted that framework in a lot of the recommendations they made. So this publication, the AVs and Increased Accessibility, the report from that workshop series is available, and anyone can download that and see that. And so again, I'll pass it back to Vic to talk about some of our recent efforts and where we're applying and implementing the inclusive framework in what we're doing.
Thank you. I'll now summarize some of our recent and ongoing shared autonomous automated driving vehicle projects. And the first is titled The Next Generation of Shared Autonomous Vehicle Designs. It's an ongoing project started in 2018 in partnership with the Robotics Institute at Carnegie Mellon University. The objective of this project is to provide detailed design guidelines and 3D reference vehicle designs that advance accessibility of shared autonomous vehicles that manufacturers can bring to commercialization. Next slide, please. So one of the ongoing sub-projects within this project collected information about wheel mobility user passenger design needs and preferences throughout the automated transportation travel chain, meaning from ordering a ride to exiting the vehicle. I think the inclusion of preferences here is really intentional. I think it's important to distinguish this from only collecting design needs, right? Design needs really talking about the essential design elements to allow individuals to successfully manage the travel chain, where preferences really speak to the user experience. And preferences are really important to consider. We all have certain expectations about our travel experiences, and everyone should have those expectations to be able to have a comfortable, positive travel experience when during their everyday lives. This study design in this one was pretty interesting. I think the study was a series of focus groups, 2 that considered small 1 to 7 passenger automated vehicles, and 2 that considered mid-size 8 to 12 passenger automated vehicles. 9 wheel mobility device users, 4 women and 5 men participated in the focus groups. The focus groups were held remotely due to the COVID pandemic restrictions at the time. The focus groups were recorded in Zoom. Each session started with an introductory presentation, short videos of vehicles in operation to acquaint the participants with the vehicle technologies. Practically all of our participants were unaware of what these technologies look like, and it would be difficult for them to make comments about them without seeing them in action. The needs and preferences of focus group participants were recorded for each step of the travel chain, and the transcripts of the sessions were analyzed to characterize design needs and preferences. Next slide, please. So the bullets on this slide summarize some of the key findings of the study related to the needs and preferences associated with planning a trip, identifying the vehicle, and boarding and exiting. The photograph on the right of the slide shows a passenger with a visual limitation entering an automated shuttle. I won't go through each of the bullets on this slide because the actual finding, the detailed findings are maybe less important than the approach that we took in terms of making sure that we covered each step of the travel chain. But I think we definitely understood that in terms of planning a trip, individuals who use wheel mobility devices had very different preferences to how they might plan a trip and order a trip. Certainly, there were also some consistencies in the way people wanted to identify vehicles. They didn't want their personal information to be displayed, but instead wanted some kind of trip number code or destination location on the vehicle. And in terms of boarding and exiting, certainly minimizing those ramp slopes would be very important to these individuals. And that was a pretty consistent theme that we identified during those focus groups. And what was interesting was even with the shuttle size vehicles, the larger vehicles, the 8 to 12 passenger vehicles, the main consensus among the focus groups was there certainly was not enough clear floor space for individuals to maneuver in those vehicles, particularly because of the seating design and or the concerns that when passengers might be on the vehicles that they might somehow interact with the passengers in a real negative way. Next slide, please. The bullets on this slide summarize the design needs and preferences of our focus group subjects associated with securement, riding, and handling unexpected events. The photograph to the right of the bullet shows an example of a prototype visual display that could be used to convey vehicle location during the trip, as well as some other aspects of the status of the vehicle during the trip. Some of the main findings from the focus group included the large consensus of wanting to be forward facing in the vehicle, wanting some type of automatic and safe securement, wanting a vehicle monitor to show the navigation and potentially have entertainment and estimated time of arrival, large windows so that individuals could see the external environment, and flexibility not to secure during low speed trips. So oftentimes these automated shuttles are designed to be low speed, and the opinions about securing during such trips was that that it would be too burdensome for a to secure fully during a slow speed trip unless it was really fast and automatic. And in terms of communication during unexpected events, and these are like the vehicle pulls over the side of the road for a reason that might be unexplained, or there's an obstacle or a barrier in the road, something that is a surprise to the passenger during the trip. Individuals were in agreement that they would want live access to a real person and not have to interact in detail with an interface during that particular experience. Okay, next slide, please. So now I'll talk about a different project. The next project I will summarize is a complete trip deployment project sponsored by the US DOT to bring better public transportation services to Buffalo. The location includes Buffalo's medical campus and 3 neighborhoods that are currently underserved. The objective is to provide inclusive transportation services that improve access to the medical campus and to other existing public transportation services in the city of Buffalo. Next slide, please. This slide shows a schematic of the different aspects of the project. It includes technical support and software development to improve pre-trip planning, the use of multiple transportation modes, and accessible on-demand shuttle services that might ultimately be self-driving, and medical campus outdoor and indoor wayfinding technologies. The planning phase of this project has been completed, and deployment is expected to take place over the next 2 to 3 years. Next slide, please. And so in parallel with that project, we are working on a different project entitled Enhancing Community Mobility for All. This is also a multi-year project. It was funded by the National Institute for Disability and Independent Living and Rehabilitation Research in partnership with the University Health Network at Toronto Rehab Institute and the University of Pittsburgh. The goal of this project is to build and test models to systematically evaluate innovative transportation strategies for improving access to healthcare. So would be model in it. So while the actual development project is going on, what we're trying to do with this project is use computer simulations of transportation services to best understand what the community needs might be and provide input to that development project using the results of these transportation models. Some of the research questions that we are attempting to address in this project include, for example, under what conditions do individuals with disabilities and older adults support incorporating information technology systems and shared autonomous vehicles into the public transportation system? How do information technology systems such as real-time route information and accessible shared autonomous vehicles affect rider wait times, travel and travel distances in a multimodal system? And how does the adoption of these technologies affect rider perceptions of satisfaction, safety, and the relative advantage of innovative transit systems compared to conventional transit services? So this project in essence will provide some backup and some technical support to some of the development projects that we have planned as far as in terms of the previous project that I described. Thank you.
Sorry, just looking for the unmute button. And so as we look to the future, hopefully you get a sense that while Dr. Paquette and I have been engaged in a lot of research across different transportation modes, you know, we've touched on things like the fixed route bus or paratransit, ride hailing. As we evolve and start studying some of these newer, more disruptive technologies like those shared autonomous vehicles, it's really how can we apply what we know from those other systems to these newer systems, again, across the travel chain. It's not really starting from scratch. We have a lot of information, and how do we incorporate that into this new generation of vehicles? And so just some messaging to leave you with before we hopefully opens up to some great discussion. In thinking about the future of just the vehicle itself, when we're talking about automated transportation, some things to keep in mind is really we need to think big and be innovative. Maybe we'll touch on this, but just rebranding, rejigging some existing vehicles may not be the solution to where we need to go in order to create a really inclusive mobility system. And so we want to ensure that our vehicles are really traveling across the terrains that really get people from their origins to the destinations. Think again about those safe, equitable travel services to make sure they're available for all abilities. Really think about the different user groups and making sure we're not creating unintended consequences for one user group and making changes for another. Think about communicating and getting different stakeholders involved across things like city infrastructure, again, plays a really critical role in that connection between the vehicle and the urban infrastructure. And then really think about servicing those who are in greatest need in times of crisis. So emergency planning, we're seeing that emerge more and more. How does that factor into some of the decision making we're making? And then lastly, what hopefully you get a sense with the travel chain, it's a systems approach. So yes, we need to address the design of the vehicles, the physical, the software, and the hardware of some of these newer technologies, but we also had to really embrace the system mentality across the travel chain. And to do that, we really need to engage diverse stakeholders throughout the process, not just interdisciplinary researchers and designers, but also the end users and the different stakeholders involved early in the process. Really, again, think about urban planning. As an urban planner, this really rings true to me, is really that intersection between the built environment and transportation and how they really need to work together. The idea that it's really a fleet mentality, perhaps it's not a one size fits all with the vehicle, that it could be a choice and options for different vehicles that are required in order to address the different needs. And then we know some best practice designs from those different modes. How can we, again, apply those to the travel chain when we're talking about automated vehicles? And really, it's about embracing this inclusive mentality across the travel chain. I think one of the beauties of inclusive design is that it's not an end state, that it's an iterative. We use the word process in our definition, recognizing that new technology will emerge. We will learn from evaluation and continuing to try new technologies. And so it's really about this embracing of inclusive design across the travel chain to ultimately arrive at some better solutions for all. And so with that, I think we're right on time. I just want to acknowledge the different funding agencies who are a part of this and who have co-sponsored this panel. And then I am going to leave it on this slide for a little bit, which has some of the key web addresses for websites for some of the projects and the research groups that were mentioned throughout this presentation. And I think you will have access to this presentation, so feel free to reach out to us. And then I can come back to this slide, but I'm just going to also highlight the contact information for Victor, Clive, and myself. And with that, I'm going to turn it over to someone else, I believe Clive, to facilitate some Q&A. So thank you all.
Yes, thank you, Jordana and Victor. We covered a lot of ground in the last 30, 40 minutes. Thank you again for a very, I think, engaging presentation. I realize much of this is, still, I think, emerging, both in terms of technology as well as the research in accessibility. We've got a couple of questions that have been posted to our chat, and I will maybe go through each of those right now. I think the first question that came was from John Waterman, who I know well at Michigan. And I think his question was specific to the Tiramisu app that you talked about and cognitive impairments. But I think this could be broadened, I think, to just talking about just information, trip planning as well as en route information for passengers with cognitive impairments. Some of these apps can sometimes be very challenging. That's the comment here. And so the question, I think, is, has there been any studies that you have done or are aware of that might help guide designers, engineers, when working on apps or information, kind of real-time information systems, specifically for people with cognitive impairments?
So I'll start, and if you have anything to add. So it's a great question, and I think that is one of the reasons why we're highlighting inclusive as opposed to accessible, because accessible tends to be limiting and focus only on individuals with mobility limitations. And I think we need a broader perspective by addressing individuals with sensory and cognitive impairments for sure. So, so the Tiramisu app was, again, trying to get at some of that by filtering out information. So oftentimes apps, there's so much noise that you're bombarded with information. So how do you distill and tease out and have it start predicting some of the behaviors and the decision making that a user traditionally does? And so that is part of the design of the Tiramisu app, was at the time to really filter that out. So that is one research study we've been a part of. I haven't been a part of any others with cognitive impairments particularly, but I have done some research on why individuals with various disabilities do not use fixed route systems, right? And then rely on some of these paratransit door-to-door systems, and how to, because they're so costly, a lot of transit agencies are really trying to drive more people, no pun intended, back onto the fixed route system wherever possible. And oftentimes with individuals with cognitive impairments, the research shows that it's the complex, the transfers that often require, that's the pinch points for individuals with cognitive impairments, that when you have those complex trips, it becomes more challenging. So if there's a way to focus on those specific types of trips for those individuals, then we can start being more specific and guided in design recommendations and more targeted in some design solutions. But those are the only two studies that I can speak to personally. I don't know.
Yeah, thank you, Jordana. I think you covered just about everything. And I guess to answer John's question directly, I haven't been involved with specific user design interface studies that focused on the needs and preferences of individuals with cognitive limitations. I can say that in general, I think this means that, I think that there's an opportunity for, in a sense, personalized communication systems within these vehicles and within or throughout the travel chain, in which the auditory and cognitive displays would be hopefully designed in such a way that meets an individual's needs, which means that there's probably going to be great variability in the way that the interface looks like. As Jordana mentioned earlier in the presentations, it's not going to probably be a one size fits all. We're going to have to adapt the technologies and communication systems and design considerations throughout the travel chain to individual users if we want to help support the needs of those individuals with limitations that are not often considered in design.
Thank you, Jordana. We'll move to the next question, which I think is also very interesting. It's from I don't see the name of the person that has posted this question, but I will read it out here. Can you speak more about how these technologies relate to healthy aging with physical disabilities, including those with multiple impairments?
Do you want me to start, Vic?
Yeah, you go ahead. You unmuted before me. Go ahead.
Okay. So I think it's a really interesting question. I think a lot of these newer technologies, yes, the goal is to address the needs of those who don't drive or have severe disabilities, but I think in order to fully be successful and economically viable, they also have to provide a service for others as well. So this idea of having transportation options, choice, and on-demand service provides flexibility for people who might just not want to drive if they even can drive, right? It's providing another mobility service. Mobility as a service has become a buzz term, but it's this idea of building in options and choice. But I think the question is quite interesting because it brings up things that I struggle with in thinking about those unintended consequences. So people rarely just have one limitation, right? There's often some cross-cutting limitations. And so it's about making sure we're addressing or trying to address one problem without causing a new problem for people. I'll pause there and let Vic respond to.
Yeah. I would just add that I think these new potentially transformative transportation systems might provide older adults with access to healthcare services, social services, access to recreational activities that they might not otherwise get. So if we've eliminated some of the transportation barriers with these new automated transportation services, and people can get out in the community and access services that they would have accessed had they been able to drive, then that's a good thing. That's going to be healthy both physically and psychologically. The other issue we might want to think about is not only for the individual rider, but for the family and caregivers of that individual as well too. So we think of the mental health, the physical well-being of, say, an entire family who might be interacting with someone or worrying about whether or not they're accessing the services, the healthcare services that they need, and so forth. And maybe it reduces some of the pressure on other members of the family or other loved ones who care about that individual. So I think there are opportunities here for automated transportation to fill some of those voids and meet those particular needs.
Thank you, Vic. And Jordana, we have a next question, which I think is prefaced with a comment and actually a lived experience with a disability. This is a question and a comment from a PhD student with a mobility disability. The statement is that this person exclusively relies on bus and paratransit for her travel, and often finds, irrespective of the design of technology, it's the human interactions that often are the most important factor in determining whether or not it's a good or a bad trip, or whether it's even accessible. And so the question then is, as part of your research, have you also been involving transit workers, or maybe the transit providers or operators in thinking about design and technology?
Go ahead, Jordana.
Okay. So I can say really interesting, and that comment, I really appreciate that comment. And we have heard the same thing from different end users and individuals with lived experiences who engage in some of our research projects, specifically as it relates to things like securement. And that was one of the reasons that really sparked our interest in studying things like securement, the traditional wheelchair securement on fixed route vehicles, for example. One of the reasons for that low percentage of compliance that I mentioned is often that interaction between the operator and the rider. That experience between the two often causes a lot of the low satisfaction with that experience for both the operator and the rider. So we've done extensive research on different securement systems, advances in securement, both in a lab setting and in the field. Our transit agency has some of these newer technologies that require less engagement from the transit operator. And we've also done some interviews with those transit operators to learn about those experiences. How does it, what do they like or not like about those newer technologies? So we are trying to talk to the operators of these vehicles. But the interesting thing as we are moving to this automated transportation system and those level 4, level 5 types of vehicles that Vic was talking about, that eliminates that human component in many situations, right? And so while it takes away the bad part that might happen from that interaction, and the things that Vic and I are studying now is, how do you build trust? What happens in those unexpected events when an operator would usually take over, address a malfunction or address a situation? What do you do in those situations? So we're trying to talk about what is the good and bad when there isn't even a human on the vehicle. So a really interesting question, but I'll stop there and have Vic.
Yeah, so I'll add to what Jordana mentioned about this. So one of these, these human interactions, I think, are really important for the positive and the negative, but they are therefore in some ways uncontrolled, right? So you have someone who's a vehicle operator that's not very supportive of his or her passengers. That can create a negative experience for the passenger with, say, for example, who needs to secure a device on the road. Now you have another driver who's extremely supportive and helpful, and that changes the whole experience, right? So that variability is tricky to handle, but we have studied it, and Jordana and her research team have even talked to the operators of vehicles and their own experiences in interacting with people who, for example, require some kind of assistance related to securement. I would say that the automated vehicles probably will never eliminate the interaction with operators, but will modify the interaction with operators. So in our studies, individuals do still want to have the opportunity to interact with, quote, a real human somehow. And what that looks like, though, may change. For example, you can imagine an auditory system where someone's able to ask for help or ask for information during an unexpected event, or some clarification on why the route is a certain way, or why the vehicle is operating in a certain way. You could also think about video conferencing on these kinds of vehicles in the future as well, when people need access to, or want access to, someone who's monitoring and potentially even having some degree of control on the over the vehicle. So I think stay tuned for that. I think it is going to be a feature of some of these automated vehicles in the future. The demand across, I think, all potential riders is quite high for it.
Thank you both for that response. We have only just a couple of minutes left. We might have time for one more question that's in our queue here. But before that, I just want to make sure that we thank all of the attendees and our wonderful presenters. If we were not able to get to any questions, our staff will try to respond to them, following this webinar. We have one question here. It's prefaced again by a comment saying that here, at least in Michigan, where this attendee is at, he's heard from a lot of individuals that they would like to be involved in the technology design and development process. And I'm guessing these are maybe not all, but perhaps many of them might be individuals with disabilities. And so the question is, are there any initiatives that you are aware of that to include individuals with diverse needs in these processes of technology design and development.
Yeah, I know we're short on time, so I'm going to be very quick. But yes, the answer is yes, at different levels. So in the academic, in the research space, we are constantly, and we know of other researchers who are constantly engaging diverse stakeholders in the process, including many individuals with disabilities. The other thing I would just mention, I just read an article this morning, I think it was in Forbes, that Waymo, for example, Vic mentioned Waymo, they are launching an accessibility group in their design process. So recognizing the value and really trying to commit to this idea of inclusion in their designs, they have formalized a committee or a working group within Waymo to work on this. So in some ways, it's a formal type of program to ensure that different end users and different lived experiences are included in the design process. So that was the quick response. So yes, the answer is yes.
Yes, and I'll just add that to the person posing the question, right? Still, if you're still interested in learning more about those initiatives and opportunities, feel free to email both either of our presenters or even me or even our staff at the Ideal RRTC. With that, I think we are out of time. Our presentation recording will be made available, so you should be getting an email about that perhaps in the next week or two. Thank you again to Jordana Maisel and Victor Paquette. Appreciate your time and sharing your knowledge with us. Allison or Anna, if you have any last comments or instructions for us, please go ahead. If not, thank you all.
Thank you everyone for joining us.
We're going to end the webinar right now, so I hope you all have a great day. Thank you so much.